To understand artificial intelligence (AI), we first need to understand the human brain, and specifically how neurons work within that brain. Neurons are specialized cells that transmit information through electrical and chemical signals throughout the brain and the nervous system. In the same way that electronical signals are through circuits in a motherboard that goes to various different components to make the computer work. Obviously, in terms of the human brain and how data gets into the brain and its associated neurons, is different to how a machine would process data, but the principle is kind of the same. You see, a human brain gets data through electrical signals, through sensory information such as the eyes or the ears or the nose, etc. And without going into the science, this forms what is known as neural pathways, which is how the data is processed, stored, and retrieved. And this is how basic memory forms, but this is a very vast, complicated structure. We are talking around 86 billion neurons. Yes, that's billion with a B. Now, the reason for this quick science lesson was because artificial intelligence (AI) is based on neural networks, and the concept of this brain is mimicked into machines. Now, this is where the video and the concept of AI and machine learning gets really cool. Because now we understand some basic human science of the brain, let's compare this to how the artificial brain works in order to mimic the human brain and its neural pathways. So an artificial brain is known as a neural pathway, which consists of neurons, which are all these little grey boxes. Now, these tiny neurons obviously mimic the human brain. And to do this computationally, the neurons are grouped into several layers, as shown on the screen. Now imagine those layers in transparent form, and each of these layers can have weighted connections. And these weighted connections are mathematical connections, which you can see on the screen with the black lines. Now, I won't go into all the complicated maths because it's really clever on how this works, but essentially all the maths and the weights and the averages make the quickest path for the neural pathway for the data to go and get to point A to point B. In other words, think of this as an artificial version of your neural pathways in your brain, but in a digitalized format and on steroids, which make it far more superior than your own human brain, especially given computers can scale with their technology and compute power, as well as the vast amounts of data across the internet from all the greatest minds in the world and history. Now, let's expand and apply some of these AI concepts into the real world using another real-life analogy. Let's imagine we have a fast food restaurant that has grown extremely popular due to its legendary burgers, among other items. And as a result, the fast food restaurant has decided to go online with a digital app in order for customers to order its food. Now, in the days before AI, this app would have been programmed using traditional or classical approaches known as predefined rules. That is how a back-end database would be searched and queried for data analytics and marketing trends, including sales-related data. However, this old-school approach had its limitations in that it was restrictive and not personalized or dynamic. It was very static, e.g., you'd have a rule something like, if a customer buys food item X, then recommend food item Y, based on a load of logic and research of what customers commonly order. Now, fast forward to today and into the future and the world of artificial intelligence, AI, and machine learning, ML. And combined with an abundant amount of worldwide data online that can be harvested, mined, stored, processed, and even used in machine learning models, of which our fast food restaurant and its app could be a great use case for machine learning. But before we go into machine learning, let's just recap what artificial intelligence, AI, means in the context of this fast food restaurant. Now, AI is a broad field focused on the development of intelligent computer systems capable of performing human-like tasks. And this broad definition is important to remember for your exams because there are many types of AI. Now, we will touch upon one type of AI known as machine learning, ML. And machine learning is a type of AI used for training machines to perform complex tasks without explicit instructions. In other words, to perform artificial intelligence, hence it's a subset of AI. Now, the whole idea of artificial intelligence comes down to a very important asset known as data. Oh yeah, data, data, data. And what the machine learning model does is it finds patterns hidden in that vast amounts of data. And this whole process of creating the model and inputting data and doing all these calculations is known as training the data or training the model. Now, to give you a practical application of how this could work in our fast food restaurant, let's say that same app database that was used in the classical programming is still used here and it stores all the customer orders and receipts, aka the sales inventory. However, this old school approach is a great use case for the use of machine learning, and this is where AI comes and takes this to another level. Because remember, the AI machine learning model takes vast amounts of data, and not just any data, but data across many different sources. This vast amount of data allows you to make better insights and predictions based on the data model, and far greater than you could have done with a classical programming predefined rule. However, like with everything, it's important to clean up and tidy the data before putting it into the machine learning model. Because any data model is only as good as the data that goes in, e.g. good data in, good data out, bad data in, bad data out. Now, as mentioned, the ultimate goal of a machine learning model is to output predictions based on the vast amounts of data across the different data sources that the data model has collated, processed, and even done pattern analysis on. So, a very practical example for our fast food analogy. Let's imagine we have a machine learning model that has collated a load of data across all those sources. And to make use of this model, let's say we have a process flow that looks like this. And let's say our AI model has figured out there's been a trend online for milkshakes and that customers might want milkshakes with their usual order. Because hashtag milkshake is gone viral and most fast food restaurants online would have picked this up and tried to sell milkshakes as part of their fast food offering. That is until the AI then picked up that the fad was over and milkshakes are no longer popular, and the sales data has also gone down, so we no longer recommend milkshakes as part of the AI recommendation. It's important to note here that without the AI and its subsequent machine learning model, we would have never known that milkshakes were a fad, and when the fad was over, so in classical programming, this would have probably never existed because the thought of predefining this rule may never have occurred. Especially if this fad was temporary, for example, only lasted a few hours on a specific day for a specific time. Now, in the final part of this video, I want to go one step further and say to you that there is more with inside machine learning. In fact, there's quite a lot more, which is known as deep learning, and with inside deep learning there is generative AI or Gen AI. Now, starting with deep learning, this is an advanced version of machine learning or machine learning models. As once we have built a very complicated, vast amount of data within a machine learning model. This model can be connected or used with other models to solve very complicated problems or maths problems in a very similar way to how the human brain and its neurons, as explained earlier in this video, work. And within deep learning, there is one more subset, which is known as generative AI or Gen AI, which then takes very complicated, vast deep learning models, which remember is mimicking the human brain with a load of neural networks, which are artificially generated and work within a very complicated deep learning model, which is fundamentally based on very complicated science and maths. But the ultimate idea is that generative AI is a self-creative AI. Meaning all these artificial neural pathways, just like in our brain, can make it become creative and use all the data within the deep learning model to do creative things, such as make images, make conversation, make music, and in our fast food analogy case, if we had an advanced generative AI model which was based on a very complicated deep learning model, it may, after all its data analysis and pattern finding, identify that a new burger needs to be created, and this is called the milkshake burger fries. And this will be the next big thing and will make you millions and millions of pounds. Oh yeah. And there you have it, folks, machine learning and also the advanced versions of machine learning from deep learning and generative AI. If you found this video informative, it would be awesome if you could like and subscribe to this channel, as this channel cannot grow without your support, and I would love this to go to more and more people on YouTube, as I try to make these videos to make it easier for other people so they don't have to learn and research all the stuff I did to make these videos. Thank you for watching today's video. I hope you enjoyed the content as much as I enjoyed creating it. If you would like to see more content like this, it would be super fantastic if you could leave a like and subscribe to help support this channel's growth.